Alright, today we're going to again expand on what we did yesterday. It's the same content. We're looking for exact um, exact trigonometric values. Okay, so we're not simplifying, we're not rounding. Again, you'll see in all the instructions, no decimals. We are looking for the exact value. We're going to use the unit circle, and we're going to use the relationships that we came up with in that prior video, which is that sine is the y value. Cosine is the x value of a named degree. Tangent is y over x, or sine over cosine. And what's really a little bit different today is we're kind of mixing several things all together. We're not just using sine, cosine, tangent. We're also using their reciprocal ratios of cosecant, secant, and cotangent. We're not just going from degrees. We are going from degrees. We're going from radians, but all of this stuff kind of comes together. So what I'm pushing you guys towards, and probably a little bit out of your comfort zone, I acknowledge that, is a fluency of thinking about these things in multiple ways all at once. Again, not just focusing on the basics, our basic trig functions with degrees. That we're kind of blending these worlds and working on our fluency. Okay, so there are some things that we need to keep in mind. Let's start with the fact that tangent, and I'm going to make a couple notes over here. Tangent is going to be y over x for us. So tangent of 30 degrees, and you'll notice I have the unit circle pulled up. For 30 degrees, our y value is 1/2. Our x value is root 3 over 2. This is actually one that we did yesterday, but I'm going to go ahead and work it out longhand. So our y value is 1/2 over our x value of root 3 over 2. Again, any time we divide a fraction by a fraction, we would simply say 1/2. We're going to flip it and multiply, times 2 over root 3. My 2's are going to simplify, and I will end up with 1 over root 3, which I cannot leave in this form, so I will rationalize, and that's going to give me a final answer of root 3 over 3. If you look back on our note sheet from yesterday, that is the same answer. Sine of pi over 4. Again, I kind of feel like I hit the lottery every time I get a sine, cosine, or tangent, because they are really simple. If we look at our unit circle, we know that sine is the y value. Again, that's alphabetical order. Cosine is going to be the x value. Sine is going to be the y value of pi over 4. So we are dealing with this right here. It's root 2 over 2. It is already in simplified form, so there's nothing else for us to do. We just had to identify it and label it. Tangent of 60 degrees. So tangent is our y value over our x value. I will list that again, y over x. I want you guys to hear that, see that, think that, dream about it at night. I had a disturbing dream the other day. It was about the unit circle, and nothing like dreaming in terms of math. So we have our y value of root 3 over 2 over 1/2. Again, flip and multiply. These 2's are going to cancel, and we are just going to be left with root 3. Since these are quadrant 1, you guys would notice that that they are actually on that note sheet, so you can kind of verify what we are doing with these. I don't want you to copy it over from your note sheet, but it is a good place where you can check. So pi over 2 is our 90 degree. We are dealing with cosecant. Cosecant is the inverse of sine. Okay, I'm sorry, not the inverse of sine. It is the reciprocal of sine. So what we're going to do is we're going to find our sine value. Our sine value, which is the y value of pi over 2, is going to be 1, which can be written, so sine is equal to 1, and we're just going to invert that. So 1 over 1, switch to 1 over 1, leaves us with 1. Alright. Now we're going to get a little bit out of comfort zone. Let's see. Let's stretch this. And let's go to, let me see where I want to skip to. I'm going to leave plenty of these for you guys to work on. Let's skip down to, let's just skip to 6. So we're not going too far. So 5 pi over 6 is given to us in radians. We need to look at our unit circle and let's find 5 pi over 6. Cosine is our first value. Again, since it's cosine, it's one that we can just identify, and that's going to be negative root 3 over 2. Cosine of 240, again, so if I'm working on number 7, is just going to be the first value of the ordered pair. So we find 240 degrees, and we automatically have our answer, negative 1/2. Let's deal with secant of 300. That is problem number 9. So again, I am skipping around some. Secant of 300. We find 300 degrees. That is in radians. That's 5 pi over 3. Secant is the inverse of cosine. Right? So what I'm going to do is I'm going to find cosine of 300 degrees. And the cosine of 300 degrees is 1/2. So secant of 300 degrees is simply 2. Alright, let's look down to one more kind of unique place. Let's look at 15 and 16. Alright. 15 is 25 pi over 6. So I'm going to figure out where 25 pi is. And I'm going to do this in a very manual kind of a way. So we know that this would give us 6 pi, 12 pi over 6, 18 pi over 6, 24 pi over 6, 25 pi over 6 is one more, which is going to put us at our 30-degree reference angle, just pi over 6, and we are looking for tangent there. So it is going to be 1/2 over root 3 over 2. Again, our 2's are going to simplify. This is going to give us 1 over root 3. We've actually solved this problem already, and we found that when we rationalize that, we can certainly rationalize it again, but 1 over root 3 simplifies to root 3 over 3. Alright, number 16. Let me see if I can erase my circle over here. Clean this up a little bit. Alright, so negative 60. We are looking for cotangent of negative 60 degrees. So that means we're coming back in this direction to here, to negative 60 degrees. Our ordered pair here is 1/2, negative, and negative 3/2. And so cotangent, the tangent would be x over y, tangent would be y over x, so cotangent is x over y, which would give me 1/2 over negative root 3 over 2. 2's are going to cancel. I'm going to end up with a negative. This is much like the problem that we just did. It just happens to be in a different quadrant. And so we are going to end up with negative 1 over root 3. And we just found 1 over root 3 is root 3 over 3, so negative root 3 over 3. I'm going to stop with those examples right there because I think that it is a thorough kind of showing, and I don't want our video to drag on for too long. But I'm going to get you guys to finish this sheet, and you will have a homework sheet to complete to turn in on Friday. All right, let me know if you have any questions. Otherwise, work hard.